number one thing what we're going to do. So the number one thing what we're going to do here is let's go to okay, you see here. Okay, you see here. I've already drawn the models here. Sample model one. Okay. Okay. So the people who are new to SmartPLS, just for them, I'll show them how to make this what I've made, right? So let's for their sake, I'm doing it. I know many of you already know that. So let's say, so for number one thing, what they need to do is they need to create a new project right from here where you see new project. Hit it, and it will create a new project. Let's say I want to call it test project. That's test project. Okay, so I did test project, and you see here I have test project here. Now it is asking me, SmartPLS is asking me to double click and import data. So let me go and double click and import my data. Okay, so let me go to trainings, UUM training, and let's say I have this. Okay, and I need to use CSV format. I need to use CSV format. Okay, I'm sorry. So this has some error. Let's do a different one. I know what the error is. Okay. So, okay. Not able to because it has anyway. So I don't want to close this because if I close it, I'll lose a lot of data. Okay, so let's go here. Let's go back here. So I'm sorry for this. Okay. So take a look at here. So I can create a new project here. I can create a new path model. It's a test path model. Test path model. Okay. So once I've created test path model, now I need to draw. When I create it, it will also ask me to import the data, and then when you import the data, it should be in CSV format. And when you import the data, it will be something like this. And when you import the data, you'll be able to see a number of things here. I will talk about that later. Let me first draw a sample model for them. Somebody who's new to it. There are a couple of ways I can do this. Okay. And then I can select items. Let's say this is commitment. No, this is communication. Rename communication. Okay. Look, I have two options: what to be shown in the model and what to be shown in the report. I can, let's say I say CMN, and I will show me a different report now. Okay, look here. Other way around, I can select all these items here. This is for benefits, and I can drop them here, and again rename benefits. Okay, and then cooperation, and then again rename cooperation. Okay, very simple and easy. And easy. It will remain red unless I connect all those. Okay, let me do it right. Okay, remain connected. That's how very simple, very easily we can make model. If I want to align it, just come here and I say align it with bottom. Oh, sorry. Align it with bottom, and it. Okay, now it has been aligned. If I want to go here, I want to keep this indicator above, I'll put it here. Very simple, very easy. Now I can run all type of analysis. I have my indicator here, right, already there. I just need to start running my analysis. Okay, so let's do next. Okay, so let's go to simple model here. I have made a simple model. Okay, look here, I can use this color palette to change color and different themes. So let's say I put a black and white theme and apply it. It will be all black and white. Really up to you, whatever you want to do. Okay. Number one thing, we need to do measurement model and we need to do instructional model. Before we do measurement model and instructional model, we need to run a couple of other screening. For example, we talk about missing values. So what if I have missing values? For example, I have missing values. For example, what do I do? This is what I do. Look, when I run any type of analysis, let's say I'm running this, I'll show you what it means. Look, it has a treatment for missing values. It has a treatment for missing values. Can you see this? Missing replacement values. Can you see this? Okay. So mean replacement value is fine. This is what it is. So if you have, what you need to do on your Excel sheet, you need to take a look at, you just need to make sure that the total missing values of the total data are not more than 5% in your data. If it's less than 5%, okay, no problem, just bring it here. First, you should be trying not to have missing values. But in the end, it's going to affect your data and your result. But in case you have it, don't worry, PLSM will take care of it. Okay, next, no highly skewed data. Okay, if I want to look at no highly skewed data, very simple. I'll just go here. Look, this is my sample data. And what I can do, this is what I can do. Look here, what is happening. I can take a look at this value, kurtosis. I can take a look at this value, kurtosis and skewness. Most common that people use is that if kurtosis and skewness values here, right, and it should be only for, just make sure gender, all those values should not be focusing on that, just the items values. Kurtosis and skewness values should be between minus plus 110, between minus and plus 110, plus 1, between minus and plus 1. That means, so take a look at here. Is that between minus and plus 1? Yes. Is that between minus and plus 1? Yes. Both values are there. Oh, this one, look here. This value is slightly out. This value is slightly out. It's slightly above minus 1. So this data is a little bit not normal. Again, this data is a little bit not normal. This data, again, here a little bit not normal. And again, not normal. So apparently our data is not 100% normal, but nonetheless, nobody can say that this is highly skewed data because I see most of my values, most of my responses for items are within minus plus 1. In that case, I can be quite sure that my data is not highly skewed. Other way around, I can run histogram on using SPSS, and I can have a look at how my data overall looks like. Nonetheless, I'm pretty sure this data, if you have this type of situation, you should be quite happy with it, right? I would suggest that if your data is within or below 3.3, then you could be quite sure your data is not highly skewed. But if your data is above 3.3 here, right, whether it's kurtosis or skewness, I would suggest you to go ahead and run and use SPSS and run histogram and take a look at how much skewed data is. If your data is highly skewed, right or left, it could inflate error in your results, right? So we are done with two parts. Number one, missing values, I already mentioned to you. Next, how to take a look at normality of your data within SmartPLS. Okay, for outliers, I already said that's not possible. At least for now, it's not possible to check in SmartPLS. You need to check Mahalanobis test in SPSS. You need to run that. And then finally, linear relationship. Well, we're pretty sure that this is the linear relationship. We are sure that our hypotheses are linear. Okay. Now, multicollinearity. Okay, so let's run number one. Let's do the multicollinearity test, and then we'll do the rest. Okay, let's do multicollinearity first. Okay, before we do multicollinearity, let's do multicollinearity first. Okay, no problem. So this is what I'm doing right now. I'm running Look here, I'm not doing anything. By default, it's path. By default, it's 300. By default, is missing value. I went here, we call algorithm, PLS algorithm, and let's run it. Let's run it. Okay, let's run it. And then go here, take a look at here, collinearity statistics, VIF value. So why I'm doing it? I'm checking whether there is a collinearity, there is a multi-collinearity issue in my data. It's a part of screening your data. So I did multi-collinearity. Okay. So looks like it's recommended that these values should not be higher than, some people say 3 and some people say 5. And I can see that most of my values are okay, except for 3.2 and 3.2. Even these values are okay because they are within 3.3, which is the threshold. Many scholars say that it's a threshold to establish that there is no issue of VIF, there is no issue of multi-collinearity in the data. So it looks like COM2 and COM3 are pretty close to multi-collinearity issue. Nonetheless, it's within the range of 3.3. Now, if you see the values in green, this is what PLSM does. You know, in most analysis it runs. As long as the analysis results, the values are fine, it will show them in green. If the values are on the border of danger area, the threshold value, then it will show them in gray. And if these values are beyond those threshold, whatever the given number they say that it should not be above that, then it will show them in red. Okay. So looking at VI value for the collinearity diagnostic, multi-collinearity, looks like our data is almost has no problem of multi-collinearity. Okay, so we are done with 3, missing value, multi-collinearity. Okay, now there is another thing. We need to do. Now we need to check CMV. It's called common method bias, CMV, or common method variance is called, right? Now what we do for CMV, let me make a new model for CMV. Create new path model, CMV. Oh, it's already there. So look what I'm doing here in CMV. Look what I'm doing here. Let me remove it so you understand what I'm doing here. Look, I've taken all the variables in my model. It doesn't matter whether they are independent variable, dependent variable, moderator, mediator, it doesn't matter. I've taken all the variables here, and I am bringing a variable here called weather. Okay, just call weather. And I am connecting all my variable with this, as the variable is the dependent variable. Now what I'm trying to do here is basically it's called full collinearity assessment. This procedure is called full collinearity assessment. It's a relatively newer way of checking CMB or CMB, common method bias, within PLSM or within CBSM. Why I've taken weather here? You just need to take randomly any variable. Take any variable random. It should not be from the same data. That you have collected from your respondent. So let's say I have gender here. Now gender may be related to gender of the same respondent who have given me this response here. I will not be taking. I'm taking the weather, randomly weather of last 1 year data of weather of Pakistan, and I put them here. Now I know for sure that weather has no relationship in my model. Number one, weather has no relationship with the phenomena I'm assessing. As a result, I believe that weather has no relationship whatsoever with these variables. Okay, so what I'm doing here now is in order to check. Now we remember VIF value. We remember, right? VIF value. So now let's do this. In order to check CMB, first we run the VIF value just to check the multi-collinearity, right? Now we should be checking multi-collinearity first, and we know the multi-collinearity, so I'm not doing it again. and take a look at it. All the values are under 3.3, right? Once we are done, then introduce an extremely unrelated variable here. Make that dependent variable. Connect all these variables to your this unrelated dependent variable, and run again PLS algorithm. Run again PLS algorithm. And now again go back to collinearity directed VIF and see if now you have problem any of the value here exceeding 3.3, and we see that no value is exceeding 3.3, which helps us understand, which helps us establish that our data has no problem of CMB. Okay. This procedure, the one I've done called full collinearity assessment. Full collinearity assessment is relatively a new way of checking CMB. The advantage of this this method is that it allows you to run your CMB analysis within SmartPLS. Otherwise, you need to do Harman's single test in SmartPLS, which is quite famous, a quite easier one to do. Okay. So we are done with CMB. We are done with missing values. I've already told you. We are done with the other multicollinearity issue. Okay, so let's go. Let's run number one. Let's run. Now I'm moving to. Let me close all these. Now I'm moving to a structural equational. Sorry, I'm moving to measurement model. Measurement model. Okay, so let me close all this so there's no confusion. This is the other one. Okay, so I'm moving to measurement model. Now, number one, measurement model means I'll be checking the reliability and validity of the data. So let's do this. Okay, I go here. Again, I go to PLS algorithm. I go to PLS algorithm. And again, I do nothing. Leave everything as it is. It is automatic, and just run it. Okay. So what we need to do, number one, when we do our measurement model assessment, number one in reflective, actually, I'm talking about, keep in mind, my all variables here are reflective, and what is the sign of these being reflective? This is my model, this is my construct, this is my variable, and the items are going out of it. If it were formatted, it would look like something like this. Let me show you what is formatted is. Switch between formatted. Look, it will look like this. If we have this type of, if you have according to the conceptualization and theory, if you have drawn the model like this, then this is formative. However, in this case, I'm doing just a reflective. Formative is for another day. Like I said, if you guys are interested, I will ask brother Mehdi, Dr. Mehdi, to have another day, and we'll come back just discuss about formative and reflective. Okay, so let's go back here and run measurement model. Measurement model and run it. Usually measurement model quite quick to run. Okay, now I need to check. So click on reports here. I need to check a couple of things. Number one, I need to check outer loading. I need to check outer loading. Now, and I'll be providing you the book for the reference. Outer loading should not be less than, this is the idea. Ideally, the outer loading should not be less than 0.708. The outer loading should not be less than 0.708. And if you look at here, PLSM has highlighted some of my values in red because they are below 0.708, right? So what should I do? Should I remove them or keep them? Well, before I remove them, I need to do a couple of tests, and then I'll decide whether I want to remove them or not. In reflective measurement, we can remove them. In formative measurement, we should not be removing any item based on these values. We call outer rates, not outer loadings. Okay. So we are done. We are pretty sure all these are fine except for these CMT3, CMT4, and value 0.578. We'll leave it as it is and move on to do take a look at a couple of other analysis. Then we'll decide what we want to do with outer loading. Once we're done with outer loading, we can go to construct reliability and validity. Right? Let's go to construct reliability and validity. Number one, Number one, I need to establish that my data, my scale and my data are reliable. Most common way to assess is reporting Cronbach alpha. Other one which has lately has become extremely popular is CR. We also call composite reliability, right? It's for reliability. However, now the new researchers have the major various other investments have come out, and the research says they say the rho, which is actually another type of correlation. It's a rank correlation. Actually, it's a rank correlation. They said this is rho is far better. They said this is very conservative. Very conservative, that means a very stringent, very hard. Composite reliability, this is too, it's not, it's actually, it's not, this is conservative and it's very liberal. In other words, it sort of provide you, it's sort of provide you or measurement of reliability. So many authors say that the rho is a better one. I would suggest just use Cronbach alpha and composite reliability. Just report these two for reliability. Right? Okay. If you're done with reliability, you're done. And apparently all these values are green because my values again should be above 0.70 here. The threshold is 0.70. All these values are above that. As a result, we are okay with the reliability of the data. Next is average variance extract. Now, they're also called convergent validity. It's also called convergent validity. Now, this value should be above 0.50, and we see all the values are above 0.50. That means they're enough. The items we have used, they have explained substantial or enough variance. If this is the case, if these values are 0.50 and above, we can retain these values which are below 0.708. What if these values, which again go back to here, what if these values, AVE, average variance extract, would be, let's say for this, would be less than 0.5? Then I would go here and I would remove at least one of these, and then I would go back and check if my average variance has improved as a result of that. So the rule is that you can retain outer load. Number one, the outer loading value should be 0.708 and above. In case it's below, don't delete. You can only delete if it's a reflective measurement, and don't delete unless you have checked average variance extract. If average variance extract, also called AVE, is 0.5 and above, well, then you do not need to remove this, leave it as it is. Again, it's okay according to here, Ringel, all these, the top scholars who have worked on PLSM, who have contributed a lot. This is their opinion. They believe it should not be removed anymore. Okay. Next, we want to check. So we are done with reliability. We're done with here outer loading, and then we come here for reliability and average variance extract, AVE. Now we want to do discriminant validity. See, we have three type of discriminant validity. We have Foreigner locker, we have cross-loading, we have HTMT. Now, arguably, HTMT is a much more advanced than Foreigner locker and cross-loading. Cross-loading and Foreigner locker are still acceptable, but many people now believe, especially the newer researcher, like I mentioned, Ringel and others, they also talk about HTMT. Now, HTMT value. So what I usually report HTMT and Foreigner locker. Usually I don't report cross-loading, right? How to assess if the Foreigner locker is fine and cross-loading is fine and HTMT is fine? Let's do one by one. Foreigner locker. Let's take a look at here. The benefits here and the benefits here. On this diagonal, benefit should have the highest value against itself. So benefits here and the highest value is not there. It has the highest value against itself. And then commitment has the highest value itself here. No, commitment has the highest values here, which means the commitment has a little bit issue with the convergent validity. So that means I'll have to remove some of my items to, sorry, not the convergent validity, discriminant validity. That means I'll have to remove some of my items. Look here, commitment should have the highest value with itself. In comparison, commitment has the highest value, the benefits here. So it's a problem here. Let's take a look at communication. Communication has the highest value with itself. Yes, with itself. right? And then cooperation has the highest value with cooperation underneath and around, yes. Shared value has the highest value with itself, yes. With all other value, with all other constructs, it has lower value, highest value itself. So it looks like here we have a problem with commitment. And commitment has slightly overlap on benefit. So let's take a look at cross-loading. Same with cross-loading. Same with cross-loading. So we have 4 items for benefit. So these 5 items for benefit should have the highest loading with itself. And if you look at, yeah, this is the case. Here, these values are lower, lower, lower. In this line, benefit here and here, benefit has the highest loading with itself. And let's take a look at commitment. Let's take a look at commitment here. And we take a look at commitment here, the highest loading here, highest loading here. Okay. And then 6, 4, 6, 4. Okay. So yeah, look, cross-loading is showing that, you know, it has almost, according to the loading values, there's not much issue, of discriminant validity. Discriminant validity means we want to establish that, you know, our, you know, the respondent of our study, they've been able to respond in a way that they are able to understand that concept A and concept B and concept 3, that means the variable, these are separate concepts. The answers should not be so much similar that it looks like they do not differentiate between variable 1 and variable 2. That's the idea of discriminant validity. So according to cross-loading, we have no issue of discriminant validity. For unlocker shows there is an issue, and HTMT is also showing there is an issue between compensation. HTMT is not showing issue with commitment, even though it is on the borderline. But HTMT is showing that there is an issue between benefits and cooperation. These values should be below 0.9. And some people say the HTMT value should be below 0.9, and some people say it should be HTMT value should be below 0.85. According to all that criteria, we have an issue with cooperation and benefits. Again, the solution is to go back here, actually go back here, and take a look at which of my items have extreme overlap. And we're talking about cooperation and benefits. Which of the item between benefits and cooperation have their high overlap, and try to remove them and then see if the problem exists, right? So you keep doing it unless you achieve it. If you don't achieve it, then you know, if there is an issue and you cannot solve it, then unfortunately you'll have to remove one of the variable. Either cooperation will have to remove from the model, or the benefits will have to remove from your model. Okay. So now we are done with 2 parts. When we're done with measurement model, so first we did outer loading, then we did reliability and conversion validity, and then we did discriminant validity. So we are done with measurement model, and so we are done, and we believe that there are some issues in our data as far as reliability and validity is concerned, and we should address them before we move on to structural relationship assessment. However, just for the sake of this, our session, I'll not be working on that. I'll just go straight to structural model and run it for you to show you how to do your structural assessment. Okay. So let's do structure. So I'm going to bootstrapping. For structural application, remember for this we did PLS algorithm. Now I'm going to bootstrapping. Now in bootstrapping, we just need to make sure that do parallel is selected here, complete bootstrapping, and one tail. And even though some people believe that two tail, I would say one tail. You can use one tail, no problem at all. Bias corrected. And leave everything as it is. You just need to make sure here you put 5,000. Just for the sake of this video, to run it faster, quicker, I'm doing 500. You should be doing with 5,000. Okay. So let's run bootstrapping. See, I've used only 500 and still sticking time. Okay, this is the issue. This is the reason I use only 500. I guess we're almost done. Okay, there we go. Okay. Look, so it gives me, when I run this, it gives me, and if you remember, all of my hypotheses, all of my paths are direct here. We don't have indirect, we don't have mediation, we don't have moderation yet. We'll bring it later. Okay. So this is our bootstrapping result, and according to bootstrapping result, I'll go to path coefficient, right? And I'll take a look at my results. Very simple, very simple. Original sample mean, these are actually beta values, right? Non-standardized, this is standardized values of regression. This is standard deviation, t-statistical value. Take a look at here, p-value. Very simple. We can determine whether our relationship between communication and cooperation, shared value between cooperation, benefits and between cooperation, and commitment and between cooperation. We can determine these relationships according to our hypothesis from here. According to our results, benefits has a significant relationship with cooperation. Values are much below 0.05. Likewise for commitment. However, the relationship between communication and cooperation has turned out to be insignificant because these values are bigger than 0.05 actually much bigger than that. Likewise with shared values and cooperation, we see the value is just on the borderline because it should be smaller than 0.05, and you see that the value is just on the borderline. Nonetheless, this hypothesis has been rejected. Okay. Okay. So what else we need to do? That's about it. That's about it as far as the structural equation modeling of direct hypothesis is concerned. Okay, let's go to another model where we have mediation model. What if we have a mediation model? What if our argument is a commitment has a mediation relationship between this and this? Okay, if this is the case, let's run our mediation analysis. Again, bootstrapping. Again, everything remains the same. You should be doing 5,000. I'm doing 500 just to run it quicker. Let's do it. Okay, so now we have, again, we can go to path coefficient here, results, and here we can see the direct relationship based on our this model, the direct relationship between this and this, between this and this, between this and this. Okay, and we can also take a look at these are the direct relationship and these are indirect relationships. So let's take a look at first direct relationship. Okay, so we see that benefits and commitment still are significant, commitment, cooperation significant, communication, commitment significant. However, communication and cooperation are not significant because these values are much above 0.05 and shared values. So these three actually have been rejected, or these three hypotheses. If we have these three hypotheses, we cannot accept them. These have been rejected. This relationship has been insignificant, while these relationships have proved to be significant. Excuse me. Okay, what now? Since we have mediation going on here, so basically mediation most probably our hypothesis that the shared value and cooperation has a relationship mediated by commitment, or benefits and cooperation has a relationship mediated by commitment, or benefits and cooperation has an indirect relationship through the mediation of commitment. If that's the case, and apparently this is the case because we have run mediation is here. So let's go to specific indirect here and take a look at specific indirect. So what we see here that two mediation, I mean mediation of commitment between benefits cooperation is a significant. Mediation of commitment between communication and cooperation is significant. However, commitment as a mediating force between shared value and cooperation has proved to be insignificant since this value is much bigger than 0.05. Okay, so what we have done here is that so far simple model, and then we run mediation model. So however, we can also run the moderation model. We can also run the moderation model. We can also do moderation in explicit. Okay, so what I've done here is that if you look at here in my earlier model, I had not taken long-term orientation. Now I've brought in a new relationship. Now I've brought in a new construct here we call long-term orientation. And we are hypothesizing that the relationship between commitment and cooperation is moderated by long-term orientation. If this is our argument, if this is our hypothesis, what we need to do, we need to treat long-term as a moderating variable. And how we'll do that? Number one, we'll bring it on here on the canvas and connect it to the DV to the second variable on which we want to check the mediation relationship, because we are saying commitment has an impact, or commitment is related to cooperation, but this relationship is mediated by long term. So I brought the long term here, I connected it to cooperation, then I could right click it and I said add moderating effect. Let me say this again. Commitment has a relationship with cooperation moderated by long-term orientation, and then I click, then I brought this long-term here, connected it to cooperation. After this, I click here, right click, add moderating effect. Now, SmartPLS is smart actually. It already knows cooperation is my dependent variable. However, it wants to know which one is my moderating variable. And I know my moderating variable is long-term. Independent variable, I know commitment is my independent variable, right? I'll select product indicator, I'll leave everything as it is. Product indicator is most recommended one, even other one, some people also use a two-stage, and other one, however, product indicator is the calculation method is the most recommended one. Let's run it. Okay. Oh, before running, you see that now I have a moderation effect here as a result of adding, right? And I'll name it commitment into long term. Essentially, this is what moderation is. Essentially, this is what moderation is. These two values are being implied. Whatever the beta values are, these are being multiplied here. And I'll say, okay. So I know this is my interaction effect. This is my interaction, this is my moderating variable, and this is my moderating effect or interaction effect. Okay, let's run it now. Let's run again, go to bootstrapping, calculate, bootstrapping, and then complete bootstrapping. Everything remains the same. Again, I keep it 500 just to run it quicker. It still is going to take a while because moderation takes much longer. So let's run it. Shouldn't take more than a minute, I believe. We are just at the end of our workshop or session. Right after that, I believe we will be doing Posthoc analysis, and that's about it. We'll be done with this, and then we'll open the floor again for the question answer. I think that'll be the end of it. But before that, let's do this moderation analysis. Once we are done with that, then we go and do Posthoc analysis. I need to show you what this Posthoc analysis are. Done. Okay, there you go. So now you see, earlier when we check our mediation results, we check our mediation results from specific indirect. But that's not the case with moderation. Now look here. Yeah, right here. This is the moderation term, right? So when we run the moderation, look, again, benefit commitment has direct relationship, perfect. Commitment cooperation, perfect. Communication commitment is also good. long-term computation is good. However, shared value commitment are still insignificant. And our interaction effect is also significant, which means the data shows that long-term has a moderating effect on the relationship between commitment and cooperation. If that's the case, we are done. We have done a lot. Okay, couple of other things we need to do. We also report R square. Usually, I would take R square value from R. Okay, I'll take R square value from R. Let me go here. Mediation model. Okay, I take R square. We also report R square value when we're reporting a structural model results. So how do we do that? Very simple. When we run PLS algorithm, we get R square value here, right? R square value is extremely important. It also appears here as 0.747, 0.575. So you can just note it down, and when you report the structural modeling results, you can report it right there. What does R square mean? Is the variance explained by these variables in commitment. That means 0.575% change in commitment is possible. If you add one number to benefit, one number to shared value, one number to this, you will see 0.575% change in commitment, right? Likewise, 0.747 is the variance explained by all these variables in cooperation. Okay, one more. Effect size. F square. Okay. We also report effect size when we are reporting structural equation model, when we are reporting our final results. Effect size means what? Effect size means they're saying that, okay, we understand the benefits, shared value, communication affects that much to cooperation. But we don't know which one of these has, if we remove communication, if you remove everything, alone how much they are contributing, alone how much communication is contributing. And whatever how much communication is contributing variance to cooperation, whether that is significant or not, whether that is big or not. Very simple for that, because this is a combined effect. If you want to see one by one how much each of this is contributing, we will take a look at here at the square value. So according to F square value, and keep in mind, we'll take a look at just the endogenous variable. So which one we have endogenous variable here? We have commitment and cooperation. So we'll take a look at just commitment and cooperation. Commitment. Benefits is contributing 1.165, right? And that's pretty inflammatory, actually. I'm pretty surprised. It's pretty high, actually. It's pretty high. Anyway, usually if the value is 0.02, less than 0.02, we call it, it has a low effect size. If the value is 0.15 and above, we call it moderation, or we call it, a medium effect size. And if the value is above 0.35 and above, we call it, it has a very high effect size. And if you look at here, leaving this 1.165, this is abnormality, actually. There's something wrong. Remember, benefits and commitment has a very high overlap when we check the discriminant validity, just because of this. You see, our results are wrong. It should not be more than one. It cannot be more than one. And here we are seeing 1.165. So here, if you look at cooperation, is explained by benefit by 0.49, which is high, very high effect size. Commitment has a, somewhere between high and low. Communication has a very low, negligible, because it's smaller than 0.02. And likewise, cooperation has no effect, because, and then shared value as, again, is negligible. They say if the effect size is less than 0.02, just remove those variables. That's what they say. Now it's up to you whether you remove in your. That means they're saying that they basically these variables are not much contributing. They have insignificant contribution to the variance in your mediator or in your dependent variable. Okay, so we are done. We are done with. Okay. Last thing I want to do. I want to do what do you call posthoc analysis. Okay, how would I do Posthoc analysis? Let me stop this and let me show you my browser. So last thing. Show you my browser. Okay, where's my browser? Okay. This is the Daniel Super website. This is Daniel Super website. If you take a look at this, is what it is, Daniel Super. And Daniel Super has various calculators, and many researchers use it. It's quite it's normal to use Daniel Super for sample size. And remember, I talked about sample size. This is the sample size. This is the calculator, a priori. Because you'll be doing structural equation modeling, then you should be using a priori here to do it. Okay. Let's go straight to statistical power. And here, okay, statistical power and multiple regression also. Okay. Okay. Now, what do I mean by why I'm doing post-hoc statistical analysis? Technically, in order to check how good our results of our structural model is, we should be doing post-hoc analysis, especially if any of our hypothesis has been proved to be insignificant by high p-values, that means much bigger than 0.05. We should be doing post-hoc analysis. Basically, we want to check whether our total model, our sample size, our R-square value have significant statistical power to explain this relationship or not, right? Especially when we have insignificant relationship. So what we want to do, we want to number one, we want to put how many. Let's say we have 5. How many we had? Let me check. How many we had? We have 4 predictor. We have 4 predictor. So we have 4 predictor here, 3 mediation, 3 moderator, 1 observer R-square. What was our observer R-square? Okay, so I'm taking R-square mediator right now. So then we'll have 3. Okay. So 3 and then 0.575. Observed value is 0.575. Probability level is 0.05. Sample size, I think it's 400, yeah? 400 sample size. And just calculate. Bingo, we have 1. That means 100%. They're saying there's enough statistical power of your model to explain the relationship. That means if we had any insignificant variable, we cannot say it's because of the small sample size, it's because of the small square R value. It's because of nothing, that's how it is. The statistical power shows that there's nothing wrong with our values, there's nothing wrong with anything. This relationship, which is insignificant, is actually insignificant. There's nothing wrong. What if we had smaller sample size? What if we have smaller observer R-square? Okay, let's take a look. Calculate. Okay. Look, it's 0.9, it's still significant, right? What if we have 50? Let's say 50 calculate. Now it's 0.84. Okay, as long as this value is 0.8 and above, you can say your model has a significant statistical power, does insignificant relationship, or actually insignificant relationship. There's nothing wrong with the statistical power, with the sample size or the regression values or the alpha values of your model. Okay, that's about it. This is what I wanted to show you. Let me stop and let me show you my slides, because my slide has a couple of other important information that I want to share with you. Okay. So I have put all these values here, for the reference. And look, all these values are here for reference and everything. Q-square, I've not done Q-square. I'm really sorry. We're short of time. I've not done it. Actually, it's pretty easy Q-square. Let me do Q-square. Actually, this is called blindfolding. This is for prediction. A lot of people do for prediction. It's pretty simple, pretty easy to do. Let me do it. Okay. So let's say I want to do prediction. I have predictor model. I want to do yes. So what I'll do, I'll go here and I'll select this. Usually after structural model, first thing, all the relationship. Along with this, we explain for results for each hypothesis. Then we explain the results. Along with this, usually we also explain the total variance, which is R-square value. Then we explain what we call effect size. And lastly, we explain this Q square. This is prediction. This is checking the predictive power of your model. Predictive power. If you have prediction, if you have, this is your purpose, this is extremely important. We keep as it is everything and we just run it. We don't do anything. We run it. And again, when we do the predictive modeling, we report only these two values, this value, this two value, this and this. That's about it. Commitment is an endogenous variable, cooperation is an endogenous variable. We just report these. Any value, Q square value, any value bigger than 0 means it has significant value. This is bigger than, much bigger than 0. So that means our model has enough enough predictive power. Okay, that's about it. Let me stop. Let me go back to my slides. Let me show you. Okay. So in order to report how to report it, I've taken this reporting how to report from this my recently published article here. I've taken everything from here. Look here, that's how you report it. Usually reliability and validity all come in one place, right? And then AV is reported along with them. And then discriminant validity is reported. This discriminant validity, I believe this is for your locker, right? Just like this, you can report HTML2, right? If you want to report outer loading as well, then I would suggest you, if it's not more than one page, then I would suggest you add as an extra, as an extra. And this is the model I've literally copied, pasted from there. You can literally copy. You can right click on SmartPLS where you've drawn it after your result. Right click, copy the image, and paste wherever you want to paste. Again, these are the results for each of my hypotheses. If you look at, I've taken path coefficient, which is the original value, t value, and I've given here my status, whether my hypothesis is accepted or not. Okay. That's about it. Like I explained earlier, we can do either in all of these, or we can do in one of these, a couple of these. We can talk about we can have more session about these topics related to PLS-SEM, and I'll be quite happy to conduct it for you. As long as we have enough people, we have interest, right? I'll go ahead and do it. Especially, I believe a lot of people have problem with reflective informative. We can definitely do that. Or if you want to do MGA, or if you want to understand how to run a categorical variable, we can do it. Okay. Last thing, I'll be sharing these slides with Dr. Mehdi and StyleWiki. If you go here, this is the page of Dr. James Gaskin, and here you'll find a lot of citations for all what we have talked about. Reliability, validity, whatever we talk about, all citations are here. The book, this is the link. You can download the book. The book the book of PLS-SEM. Most of things I've taken are from the same book, and you can also have a look at this book. It's very easy, very simple, easy to understand, right? Okay. And likewise, if you want to get some latest knowledge on PLS-SEM, what to report and how to report, you can have a look at this paper about PLS-SEM. Here, the link is here. That's about it. Thank you very much. I really thank all of you for being patient with me, for giving me time. I'll hand it over to Dr. Mehdi.
Thank you, Dr. Kashif, for a wonderful presentation and insightful delivery. And now I would like to ask our audience, do you have any question? If you have any question, so you can ask our presenter, Dr. Kashif, my friend, Dr. Kashif.
Hello, Assalamualaikum.
Walaikum assalam.
Doctor, my name is Farah.
Okay.
Okay, first of all, thank you for your very clear presentation. I have a question. In my model, I have both mediator and moderator variable, but I am slightly confused here. Whether what I understand is, first of all, we need to do mediation first, and then moderation comes later.
No, that was
what I-
that was the old way of doing it. Not anymore. Now you can do together, everything together in one model.
I see. But my question is, I also read about conditional indirect effect by Preacher and Hayes. So I'm just thinking whether there are similarities between these two, what do you call this, model? I mean, I want to do separately. No, I mean, I have mediator as well as moderator. Or can this also be the case of indirect conditional indirect effect? For example, if I have a mediation, that mediation is contingent upon the moderator variable. I hope I make sense here. I'm sorry if my question is
No,
not.
it makes sense. It makes sense. Yeah, I understand what you're talking about. See, Prof. Hayes, and there was another one, Zoho 2010. They have gone to a length describing various different type of situations where you can have moderation, various type of moderation, various type of mediation moderation, moderated mediation. You know, there's a lot of discussion has been happened. Even though they say there is no difference between mediated moderation or moderated mediation, it's the same. There's no difference actually. Okay, so let me make it simpler for you, because I don't know your model exactly, but let me make it simpler for you. Pick up any top tier journal of marketing, journal of management, journal of finance, behavioral finance. You will never ever see this type of discussion going on. So there are two types of things. There's a discussion for people, the ideas and solution, the problem for people who are expert in that area. This is their research area is. For example, for Prof. Ringo, Prof. here, you know, many other, even here in Malaysia. There are many out there. Majid comes is there, Prof. From USM, Prof. You know, there are many other out there. They're known for it. However, in situation like you and mine, we don't need to worry about it. Simple run mediation and moderation in single model and report it. Don't worry about it. Now, obviously, reporting depends on the type of relationship you have drawn. So let's say you have a relationship, you have a mediator, as well as, you know, you have a moderator, and then relationship between moderator and the mediator is there. If that's the case, obviously it's quite complex. It depends how you have made your hypothesis. I will suggest you, let me do one thing. Let me write my email address, Kashif.Farhat, okay, @gmail.com. Okay, I have written my email address for you and anybody else. Please share your model with me, and then I'll be able to explain how to run it and how to explain it. Keep this in mind. It's pretty simple. It's not as complex as you read in Preacher and Hayes' book, or in their book, or in their paper, or in Zaho's 2010 paper. They are going at a very extreme level, and what they're doing, they're trying to bring in any possible situation that, hey, this is what it is and how to do it, what to do it. Now, what if we don't have that problem? Then why do we need to go into that much detail? Number one, we don't have that much expert knowledge. Even in many cases, they don't know. For example, not many people know now, as far as I know, not many people know how to run formative model. Even many experts say that the issue is out there, but nobody knows exactly how to do it. So it's a kind of thing, right? I hope I have been able to help you. Email me your model. Put ABC, anything, don't show me your exact variable, and show me your hypothesis, and I'll be able to tell you how to run it and how to explain it.
Okay, doctor, I highly appreciate it. Thank you so much.
Okay, welcome. Yeah, another question, please.
Doctor, assalamu alaikum.
Wa alaikum assalam.
First of all, thank you so much for the informative session. So we highly appreciate. My question is regarding to the mediation and moderation. How can we run both of them together in one model? As we know, the effect size, F square, when you put the moderator together with the mediation, it will be, I don't know, it will be not clear or not that show the effect size between the IV and the DV. So in this case, should we run both of them in two models or on one models? Can you please, doctor, explain?
Yeah, basically, like I said, until 2015, 2015, these software had this problem. They were not pretty ready for it. Now these SmartPLS, WordPress, they allow you to run mediation and moderation in one go in one model. You don't need to run it separately. One. Now the problem with effect size is no problem. You show me your effect size, you show me the results, you show me the model, and I'll tell you how to report it, right? It's just your problem is not running mediation and moderation in one model. Your problem is how to report it, how to understand it and report it. No problem, we can help you with that. But we will run in one place. It makes no sense you will run mediation and moderation, separately for single research for for the same data. I would never ever do that. If these are two separate research, well, yes, you should be doing it as a separately. If it's a single research, no, don't do it. Put it in one place, run it. These softwares are good enough to run mediation, moderation, multiple mediation, moderation at a time. It's just what do you call matter of explaining and understanding, right? That is no problem. We can run mediation, moderation together, but if you're running multiple moderation in one model, then I would suggest don't do it. You may not get you may not get appropriate result. If you have multiple moderator in one model, then you should be doing it one by one, one by one, one by one. This is what the newest knowledge is. Nonetheless, you can run multiple moderation in single model and it still can report it. Nobody can question that. But you'll get much better results if you run multiple moderation. You have multiple moderator. You have in one model, one moderator, same model, second moderator, same model, third moderator. You will get much better results. Now, why it happened? The problem is with the way they are calculated.
All right. Thank you so much, Victor.
Okay, welcome.
Hello, doctor. I'm Ghazan Farali from Pakistan.
How are you doing?
I have a hello.
Ghazan Prasad, yes.
Yes, I'm from Pakistan. I have a question. If my hypothesis is directional, whether positive or negative, then what would be the suitable confidence interval I will take? Mean p-value, it would be 0.05, less than 0.05, or what about p-value, 1.64 or 1.96? I am confused about if my hypothesis is directional.
Okay. Your hypotheses are directional or non-directional? Please let me know.
My hypothesis is not directional first, but I took 1.96 p-value and p-value 0.05. But one said you have to take the directional hypothesis. Your hypothesis is positive. That's why you have to take t-value greater than 1.64 and p-value 0.01. So I'm confused about if my hypothesis is directional or significant.
Okay.
Mean no direction.
Right. So if your hypothesis have no direction, let's say I'm giving you both situations and you decide which one you want to do. Let's say your hypothesis have no direction. It says A has a relationship with B. It doesn't say it has a negative or positive. That's what we call non-directional hypothesis. A has a relationship with B. That's it. It doesn't say it's a positive relationship. In this case, this is called non-directional relationship, non-directional hypothesis. If this is the case, this has nothing to do with the p-value. P-value should be, I would say, if it's business management, I would say it should be 0.05, not less than that. Minimum 0.05. This is what you should be following. That means your 95 confidence interval is required. One. Number two, your question was t-statistics. Number two, t-statistics, basically, if you have directional, as far as I remember, if I'm not forgetting. If you have directional, you usually take one tail test, and one tail test, it's 1.96 t-value. And if you're taking two tail tests, if I'm not wrong, you know, if my memory is working fine.
Juice bana diya. Mango.
If it's so if it is what do you call a non-directional, then you'll be doing two tail tests, and in that case it'll be 2.58 if I'm not wrong, 2.58 t-value. So don't worry about t-value, just worry about p-value, because the software calculates automatically.
Thank you. Thank you.
Okay, so any other question, please? Somebody's asking, if I have moderation with 3 dimension, what to do? Now, if you have moderation with 3 dimension, are they categorical variable or ratio variable? Do let me know. Okay, any other question?
Assalamu alaikum, Dr.
Categorical.
Kashif.
Walaikum
Assalamu alaikum,
assalam.
Dr. How are you?
Alhamdulillah. Sajjad, give me a
Thank you
minute.
thank
Sajjad,
you
give
so
me
much,
a-
Dr. Kashif. Thank you so much, Dr. Kashif, for such a nice session. Actually, I missed you earlier, but just now I have joined, and I have a question regarding the data anomaly. Can we find out the data anomaly through using the SmartPLS? Is there any mechanism?
Now, when you say data anomaly, what kind of data anomaly? Is that
It means how we can find the error in data. Excuse
what
me.
type of
You are-
what type of error are we talking about?
Means what we say, the repetition of data or the missing values, such kind of errors, how we can identify using SmartPLS.
I'll be very honest with you, SmartPLS is not ideal for that. What
Okay.
SmartPLS rather does, let's say you have missing values. So SmartPLS has a treatment available for missing values. So what
Okay.
if you have non-normal data? SmartPLS just shows you whether data is normal or non-normal. The SmartPLS is a software, it will run any data that you will give it to, So what we do, we use SPSS to do the data screening. If you have missing value, we try to treat them right there. At least we try to identify them there, how many are there. Because too many missing value will inflate the error. Likewise, if we have CMV issue, then we better address them. If you can address them in SPSS, great. If not, SmartPLS has it. So if you want to correct something, SmartPLS cannot correct it. SmartPLS has a treatment available for everything. It will understand, oh, the data is like that, and it will run it that way. Right. It cannot change anything. It cannot do anything. If you want to make changes, correction, refinement, screening, we better do it in SPSS. SPSS is made for it.
Okay, thank you so much, Dr. Kashif. Thank you.
Okay, thank you. So somebody asked me categorical variable. In that case, if you have moderator that is categorical variable, as far as I remember, you need to treat them as what you call dummy variable. So go to SmartPLS, go to we call SPSS, go to create new variable option in data and convert them into dummy variable. As a result, you'll have, let's say you have 3, as a result, you have 3 variables in that. And to run them one by one, I believe that's the way to do it. You need to convert them into dummy variable if you have categorical moderating variable. Okay, this is what we need to do.
Doctor.
Yes, sir.
Please, we need another session for the higher order, second order.
I can do it. I'm happy to do it. I can do it any day next week. Please ask Brother Mehdi, Dr. Mehdi, to arrange a day and everybody, and we'll have it.
Inshallah. We really appreciate, Doctor.
You want to do just because do let me know what you want to do. You want to do higher order? Pretty easy, no problem at all. We can do repeated indicator. We can do a disjoint approach. There are multiple approaches we can do.
Yes, really,
you want
we
to
need
do
it.
formative? It's better we keep one topic because these are advanced topics. Then I'll have to go in quite detail.
True.
Right? So do let me know. Ask Brother Mehdi, and I'll be happy to do it for you. No, brother. Just somebody asking they use it. Not really, actually. Not really. What I would suggest is, brother, somebody's asking the equation. No, this equation works for the regression. These are structural model equations. These are actually quite big and quite different from this. This is part of it, but not the complete. What I would do, what I would suggest, go to YouTube and write algorithm, write PLSM algorithm, YouTube. And then you'll find somebody from the Europe has made this video, and he has provided a whole Excel sheet where he's giving you whole calculation, how PLSM calculates its data. And that will actually help you. Just go to YouTube, write PLSM algorithm, and you'll find that video. With that video, you'll find in the description, he has given the Excel sheet as well. Right? So I believe this answers your question.
Doctor,
yes, sir.
allow me to ask another question.
Sure.
Regarding to the mediation issue, you advise us to use Barrow and Kinney approach or Hayes and Pritchard approach?
Moderation or mediation?
Mediation, sorry.
Very simple. Hayes, the newer approach Hayes is valid, and Barron and Kenny is outdated. I wouldn't follow that. What I would suggest you take a look at this. Barron and Kenny, I'm not sure if it's the Barron or Kenny, I think Kenny alone, wrote another paper in 1998. And they admitted that their earlier paper of 1986 or something was wrong, thinking that they should be 4-step, and they agreed with Pritchard and Hayes that they are right.
Yes, you are right. You are right, Doctor.
Okay.
Thank you, Doctor.
Just take a look at that paper in 1998. They themselves accepted that they were wrong. Okay.
I will.
Okay. Any other question? That's about it. Okay, let's take a look at if I have moderation with 3-dimension done. Can we have the recording? Okay, thank you for. Okay, I'm trying to take a look at if there's some question that I haven't been able to answer. Can we apply this on secondary data? Whoever asked, Sharafat Alisa, you can, but I would if your complete data, all variable data is secondary, then I would suggest not to use PLSM. But let's say you have seven variables in your data. Your dependent variable is secondary, and your all other variables are psychometric and like concepts, constructs. Then you should use PLSM. Fine, there's nothing wrong. But what if your all variables are secondary data? Then I would suggest you go for not PLSM, rather you use eViews and other types of softwares. Okay. Okay, yes, I will provide my email address again, kashif.farhat@gmail.com. Anybody has any question that, as far as if I'll be able to help, I'll be glad to help you out. But if something I don't know, I'll just let you know that this is something I need to learn myself. Keep in mind, I'm also a learner. I'm learning. It's part of learning. We are always learning. There are always new updates are coming. So don't think I know everything. I don't know many things actually. And many things I learned, I just forgot them. I never use them. Okay. Brother Mehdi, I believe that's about it. We don't have anybody else who would like to ask any questions. So should we go ahead and conclude this session?
Hello, everyone. So do you have any more question? No. We love to listen you, love to hear you. Our expert is here, so don't try to.
Yes, Doctor, another one question, please.
Yes, please.
Doctor, regarding to the moderation. So in my case, I have mediation and moderation. So when I ran the data, the moderation was non-significant. And when I removed the moderation, the result was perfect. When I put the moderation, the result was very worse. So in this case, you advise me to remove it, or what I should do?
Well, it's hard to say really, because here's the thing. You know the purpose of moderation. When we introduce moderation, the idea is that we want to check whether the relationship between A and B is moderated by this particular variable, right? So this is what moderation does. Either moderation enhances the relationship or weakens the relationship. In your case, moderation is weakening the relationship and weakening to a level where it becomes insignificant.
Yes.
Now, here's the question. What if it's all studies about this moderated relationship? How can you remove it then?
That's why I'm asking, doctor. I'm really wondering what should I do?
I would suggest, like I explained to another gentleman earlier, do a review of your total study. See if there is some error in your data. You never know if your respondent hasn't been able to understand your questionnaire properly. You never know if your items were not fully, were not comprehensible enough. So the respondent. You never know if you're doing convenience sampling, and this is the reason you're getting such a bad result. So probably you want to check, you want to try a different sampling method. Try different things and see which one is better for you. Nonetheless, this is what the moderation function is. When you bring in a moderation, it changes the relationship, and this is what you did with you.
Okay, doctor. Otherwise, I'll contact with you.
Yes, you can. Sure, I'll be happy.
Thank you. Thank you so much, doctor.
Okay. Dr. Mehdi, please go ahead. Please go ahead. Your mic is off.
I see. Yeah. Now everybody can on your camera. Would like to see you. So now photo session, we can take your picture. Please try to take the picture from your own side. So anybody else, you would like to say anything?
Brother Mehdi, give me a second. Some people still can't see my email address. Let me see why it's happening.
Yeah. Please write your email.
Yeah, I think what is happening here is there's some.
Yeah.
Okay.
Yeah.
Okay, I'm really sorry.
Yeah, you can write.
Sorry.
Dr. Sam, would you like to say anything? Hey, Dr. Sam from Indonesia. Dr. Sam, can you hear me? Love
Yes,
to see
I can
you.
hear you very well.
Yeah.
How are you doing?
Yeah, I'm fine. Would you like to say anything?
Well, this is a great event, and I am truly thankful to your invitation. And in the meantime, I guess in a short time as well, that we're going to be able to talk to you directly about all the stuff that we're planning to do. But thank you very much. Thank you, Dr. Khan, as well. We're looking forward to have the future events with you too.
I'll be glad. I'll be glad to do that.
Dr. Takat Ahmed Chaudhary, would you like to say anything?
Okay, thank you very much. I just want to say my gratitude that it's a very helpful event for us. And thank you, Dr. Mahdi, for organizing this. And thank you, Dr. Kashif Khan, for very nicely delivering the important workshop. And I could not attend the whole workshop today because I was busy with another webinar at the same time, but I'm looking forward to watch it again in YouTube channel. And I'm looking forward to attend all your events, and I wish you all the best. Thank you very much. Assalamu alaikum.
Awesome. Dr. Hassan Ramadam, can you say something?
Thank you very much. I'm really, it's a great session, and it's nice to see you, my brother Dr. Kashif Khan, and thank you very much for you also, Dr. Mahdi Hassan, for this event. Thank you very much.
Dr. Sarafat Ali, would you like to say anything?
Yeah, I would like to thank all of you for creating such an opportunity for learning for all of the globe. And I think the people are from so many countries now at the platform. So you are doing a good job. Thank you very much.
Mr. Tohid Islam.
Yes, can you hear me?
Yeah, I can hear you.
Okay, thank you, Mahdi Hassan sir, and especially Dr. Khan for a such presentation on SAM, and hope Dr. Mahdi Hassan sir and ResearchGape will arrange this types of program for future that will helpful for our young researchers. Thank you.
Mr. Saiful, would you like to say anything? Yes.
Thank you so much for a nice session regarding our today's topic. Actually, those who are participated in today's program, I hope that they are really get something from our honorable guest and presenter, Dr. Kashif Khan sir. I hope many more program will come from this platform, and all of our participants will join with our upcoming days. And thanks again for our Mahdi sir for his unconditional support to our young generation and young researchers. Thank you.
So we are going to close our session, and I would like to give a special thank my friend Dr. Kashif Farhat for his time, and thank you all. Assalamu alaikum, and have a nice day.
Dr. Mehdi, you're going to share the pictures with us?
Okay, yeah. I only took one picture.
Please
Sure.
take enough so we can post them.
Yeah, can you open your camera? I would like to see you. Please take the picture. Mr. Saiful, Mr. Tohid, and other participants, please take the picture and share in the group. And I also try to take the picture.
Take as many as you can.
Yeah. And also those who did not talk, you can talk here. Many of them did not open your camera. We are waiting to see your face. Yeah, I'd love to see you all. Wow, great. Yeah, it's great. Now I can have a picture. Okay. Also, try to take the picture other. Okay. So, two. And try to share in the social media and the WhatsApp group. Don't feel shy. Don't hesitate to open your camera. It's your time. Dr. Hamid, Associate Prof. Dr. Hamid. You did not say anything.
Assalamu alaikum.
Walaikum assalam. Dr. Hamid Iraq, Associate
Thank you
Professor.
very much, Dr. Mahdi and Dr. Kashif Khan, for this excellent webinar. I highly appreciate your effort and your time presenting this excellent webinar, and we get more knowledge from this webinar. Thank you very much, and we hope in the future we watch more webinar in AMOS and PLS and other software. Thank you very much for you and to all audience.
Welcome. Also, don't forget to write us. What do you want? What kind of program? What kind of session you would like to see us? So if you write,
inshallah.
If you write, it will be easy to organize another program.
Inshallah.
And you people are our stand. So write us.
Inshallah.
Yeah. So now I would like to say, Dr. Kashif, would you like to say anything? Then we can finish.
That's about it. I would like to thank you, actually, and I would like to thank all of the attendees today, all of the colleagues, seniors, doctors, students. Thank you very much for coming out today and attending the seminar. I've already shared my email address with you. If you have any question, please do email me and I'll be glad to help you out. If you would like to have more sessions on any specific topic of PLS10, I'll be glad to conduct that. One, if you would like to learn other type of techniques such as neural, there's a neural, it's called machine learning, artificial neural network. If you would like to learn that, that's also being used extensively. I can conduct a seminar type of workshop for that as well. I can do FCQCA. We can do another one is called getting a lot of popularity, pretty difficult to do. It's called multi-level modeling. If you're interested in that, we can do a brief seminar, brief workshop on that. So really up to you. I'm here to add value to this group. I'm here to learn and contribute as much as possible. So please consider me one of you. Please consider me as one of the students, just like you learning. So I'll be glad to join more sessions here, whether as a presenter or as a learner. Thank you very much. That's about it. Thank you.
Yeah. Thank you. Good luck. See you again.
See you again. Take care all. Take care, you all. Bye-bye.
Yeah, bye-bye.
Thank you very much.
Thank you. Assalamu alaikum.
Wa alaikum assalam.
All the best. All the best. Thank you.